Hi roboticists, today we're going to continue our series with the universal robots, and in particular you will learn how to put a robotic gripper as the end effector of your robots. So in particular we are going through all the processes that you will need to follow if you want to deploy a real robotic application with a successful robot, and this process passes through the choice and the simulation of an industrial gripper. So, before to start, this is Learn Robotics with Ross, and in this channel has the aim to give you all the knowledge and instruments that you should have to program and deploy a real robotic industrial application. So if you want to become a robotics software engineer, subscribe to the channel and we will do it together. And you can hit the notification bell and feel free to book a free call with me to tell me about your robotics needs, or let's say technical issues that you are facing in developing your own project for yourself or for the company you are working with. So now let's get started. Okay, so what you are going to do is to deploy this gripper that goes into a universal robot. So this is a company called Robotiq that is doing and developing the hardware of the gripper for different kind of robots you can see here, and they provide also the integration with ROS. So they're gonna provide the UR5 file and all the drivers if you're gonna play with a real robot. So the first things is to download from GitHub repository the design of this gripper here. If you look on internet and you type as a query on Google UR5 Robotiq gripper, you will fall into this repository where is everything that you need to simulate the gripper and to attach to your robot. And in particular what we are going to deploy is the Robotiq 85 description, where you're gonna have the meshes, the URDF and launches. So I decided to simplify your life so you can clone this repository. I'm gonna provide the link in the description down below in your Catkin workspace. So after to have cloned this repository, you should have here in your Catkin workspace. So let's go through this this package. Here you have several files here. So the most important thing I will say is this. So this is the description in terms of URDF chakra file of the gripper. And if you go through it, you're gonna see all the links and all the joints. And the transmission of the joint is gonna be in this file, transmission chakra. And we can see here that they are gonna use as a hardware interface our position joint interface. And here they are using a Gazebo plugin to mimic it. But before to jump into the detail, I have created a launch file where we can have a look on the Rviz. What are the joint for which you can play with, and the other joints that are passive, let's say. So let's first run this launch file. I would say that usually when you download a UR5 file and you get from another repository, it is always a good practice to run a visualization with Rviz. So you just want to pass the chakra file as a robot description parameter, and then just run the node Rviz. And the most important thing will be to use the GUI to check what are the joints that you can play with. So let's run this. Okay, here we go. This is our gripper, so don't be worried about this base. It's just put here just for simulation purposes, but the most important thing that you need to know is this one. So if you wanna close this, you just need to play with this joint. So this is telling you that if you just need to move only one joint, and the other joint or the other side of the gripper will move automatically by mimicking the behavior of that joint. So what does it mean? It means that in the transmission of this joint is it is done as a mimic, and in fact the transmission we are gonna use this plugin here that is allows you to mimic the joint, and then these are this kind of joint here. You can have a look on it, but in particular these are type of joint that are moving accordingly based on the moving of this joint here. So what does it mean? It means that this type of joint are gonna be a passive joint. Pay attention to this, because this is a key for running a good simulation, and to create accordingly a Moveit configuration package in the right way. Okay, so the last time what we did is to create this package UR app YouTube, and you are gonna continue to modify this. So don't worry, you're gonna have the link to this repository in the description down below of this video. Okay, so the first things that you need to create is to create, let's say, a UR5 file that contains the gripper. This is the UR5 file that we have created last time. Well, I'm gonna provide the video link here in the top right corner of this video. So what we can do here is to create another chakra file that contains the UR5 manipulators and the gripper. So what we're gonna do is to create this file, and we're gonna call UR5. Let's say that it's gonna be YouTube, but this time it's gonna be gripper.chakra file. Basically, this is gonna be a copy. Okay, so here we are going to include another chakra file that contains the description of the gripper. Okay, here we go. We are including a end effector chakra file that we will need to add here. So let's add this file. let's call it okay. Here we go. Here in this file we are going to include the URDF Chakra file that we have seen before. That is going to be in the robotic gripper package. So this is going to be this file. This file here, and this is the most important thing. So this is where we are going to put the base link of this gripper in relation to the tool 0, which is the name of the link of the end effector of our robots. So then you're gonna have the origin of this joint, and then the orientation, and we need to set the pitch angle to -90 degrees. So you will see in a while the Rviz, what is going to be. Okay, so that's all for the end effector chakra file, because we are gonna relying on this package robot gripper. The best things that you can do now is to create a launch file where we are gonna visualize Universal Robot 5 with a gripper, with this gripper in particular as an end effector. So let's create another launch file and let's call it Rviz UR5 gripper. Okay, here we go. This is the launch file that allows us to see in Rviz our Universal Robot Model 5 with the gripper that we have just downloaded the module. So let's run this. Here we go. This is our Universal Robot 5 with the gripper that is put correctly at the end of this end effector, which is gonna be tool 0. And the position of the base of the gripper and the orientation is set here. The origin in terms of position and orientation. So if you change this value here and this value here, you're gonna have the position of the gripper translated or rotated in some other ways. So basically it doesn't change nothing. So here you can open and close, and remember that these joints are gonna be passive because they are moving passively by the moving of this joint here. And the other joint that are related to the robot doesn't change. So basically this everything that you need to know. As of now, what we're gonna have a model with a Universal Robot Model 5, where we are gonna have a gripper, a commercial gripper. And this practice is very common in industry, because rather than simulate a gripper, you would like to simulate a pick and place application by using the final gripper that is gonna be available on the market. And for this particular case, we have chosen this gripper here. Okay, if we want to simulate this robot, another step forward to do is to create the Moveit configuration package that is containing the robots and the gripper. So let's do it. I have already done the Moveit gripper config, so it's gonna be this one. So in my case, we are gonna edit the package and pass through all the steps that you need to do. And in your case, you just need to create a new Moveit configuration, and be sure that the URDF that you're gonna load as a robot description is gonna be this one, the one that contains the URDF file of your robot, and for sure the chakra file of your end effector. So let's edit. Don't worry, I'm gonna provide the link in the description down below of this repository as well. So we already know this. So the self collision, you will need to click generate collision matrix. Then virtual joint, you don't need for the moment to have a virtual joint. Then here the most important thing. So you're gonna add a group and you divide it into the manipulator and the gripper. So the manipulator is nothing new related to the last time, and what you need to do is to add a new group, which is gonna be the gripper, where the joint is gonna be only the left knuckle joint. That is gonna be a revolute, the one that we moved in Rviz, remember? And then these are all the links that are related to that gripper here. And remember that these are passive joints, okay? So these are the poses. So the 0 is going to be like this, up is going to be related to manipulator, where it's going to be up, and then open and close. It's very easy to do. So the end effector, now you need to create the end effector. I call it Robotics gripper. The group name is going to be gripper, the one that you have created here. And the parent link is going to be tool 0, so usually it belongs to the manipulator or the arm, and is where the gripper has been attached to, and you can see here, okay? So then passive joint, this is the first time that we have used. So basically what you need to do is to set up what are the joints that are moving because you are moving another joint. And if you remember from from the Rviz, these joints are moving because we are moving this joint. So then we're gonna set up the controller. This is the controllers after the modification that we made, but don't worry about that. You can skip this, and then you, as always, you can add a ROS controller file. We're gonna see in a while. Then a simulation for the perception. For the moment we don't use a perception. We are gonna do in the upcoming videos, and then information and so on and so forth. So here are the things. So you need to save this this package in the same source file of your Catkin workspace, and so I'm not going to generate the package because it's already done. So in my case I will go exit directly. Okay, so after that you are gonna have this package, Universal Robot Gripper Moveit Config. So I will always recommend you to do not configure the ROS controller directly from the Moveit package. Why that? Because you don't have the namespace for your robot, and it's very important in my opinion. So since that you haven't touched it, you should have this blank, and you can copy and paste this, and nothing new here. It's just saying that we are gonna use a follow joint trajectory controller for simulation in the software, and this is the name of the controller, effort joint trajectory controller, that is belonged to the namespace Universal Robot 5, and we are gonna have the same type of controller, but we are called it gripper controller, and in this case only these joints will make all the work. Okay. So then another thing that you need to do is to create in the launch file another launch file, and you need to call it Universal Robot Moveit Controller Manager. Okay, and then you can just copy and paste, and you will see that you're gonna load the ROS controller YOMO file that you have just created. Okay, so after that you've done it, a good practice is to check what is going on in this package. So what you can do is to launch a demo of this package. Okay, so here we are. This is Rviz with the Moveit plugin, motion planning here in particular. So here is the gripper. So you can see as a goal state open and close. Let's click close, and let's plan and execute it. You can see here that now it's closed. Okay. Okay, so and then everything is easy. So you can go to change manipulator, and then you can play as always here. So plan and execute. Okay, so here you change this. So then let's open the gripper again. Here we go. Okay, it seems everything seems to work properly, the arm and the gripper. So the last things that you need to that I would suggest it to do is to run this universal robot with the gripper in Gazebo, as is in real world. So let's close it. And let's modify our package in order to allow the Gazebo ROS control to spawn the controller of the gripper as well. Okay, this is the launch file that we have done last time. So what we will need to do here is to update this chakra file and add the controller that the gripper controller that we have set up in Moveit. So let's do it, and I would suggest always to create a new file. And here we go. I've done a copy and paste in another package to test it before. So basically it's the same thing. So we have updated the chakra file to load as a parameter in robot description. So here we're gonna set the position. We're gonna launch a Gazebo word in pose configuration. Then here we are gonna spawn the Gazebo ROS package node better. Then here we are gonna load the controllers. So here this is a file that we are about to code now. So we're gonna create here, because in this package there's no such a file here. Okay, but here we're gonna load the controller manager, and with the name of the controller that are belonging to this namespace. So don't worry about that, we are gonna see in a while. And here we need to remap to the actual namespace, the joint state, and the robot state publisher. And here the same things to run the node with Moveit that are getting from the Moveit package that we have done so far. Okay, so now let's create as a last step this configuration file. So basically it's gonna be the same, but we will need to add the gripper controller. So here we are. This is the same things, but with the exception that we have added this gripper controller, and in this particular case we have chosen a position controller as a hardware interface, and here are the gains, the tuning parameters for the gripper. Okay. So now we should have everything to test it out. Okay, here we go. This is our Universal Robot 5 with the gripper attached on the tool 0 on the link of the Universal Robots. This is spawned at 0.5 meter from the ground. I remember you that I'm gonna set up this here. So let's play. Okay, the robot is not falling down, meaning that the controllers are okay, are corrected, spawned. So here we go. We are running our simulation in Gazebo side by side with the Moveit, and then we can do some kind of, let's say, path planning. So let's start, for example, from the manipulator, and let's go to the upper position. Here should not change nothing. This is the same things as the last video, okay? And now what we can test is to check if the gripper are closing correctly. So let's change the planning group from manipulator to gripper, and then set as a call state a close. Okay, so here will be what is gonna be look like after the execution, and then let's plan and execute this. And you can see here that the gripper are closing accordingly to Rviz. Okay, so you can also modify this. For example, let's turn it only 25. So let's plan and execute. and here is opening at halfway. Okay, that's all for today. I hope that you got a lot of value from this video. Remember to subscribe to the channel and hit the notification bell if you wanna start a journey in being a robotics software engineer. And feel free to reach me out and book a call with me to discuss your robotic needs. Again, thanks for your attention, and as always, keep learning robotics with Ros.